Why is it that us building a novel kind of lithography machine is going to unlock so much more performance gains and so many more things in the semis industry that we don't have today? If you look at CMOS, today's traditional chip architecture, the kind of electronics that we are using to build our chips based on traditional silicon. So if you want better performance with these traditional chips, you can really do three things. If you think the transistor is this fundamental unit of power of a chip, you can increase how many transistors you have in a given area on your chip, increase the transistor density. You can change what kind of transistor you use. And so we see this trend where actually transistor architecture itself has become more three-dimensional over the past couple of decades, because it turns out it gives us the ability to run these transistors much faster and have much better control over these transistors. And so then the third thing you could do is actually you forget about the conventional architecture and you look to a new kind of architecture. So it could be quantum based, could be photonics, it could be something else. And we actually see that we're able to target all three of these areas with the lithography machine that we're building. In the case of shrinking the wavelength of light that we use to do lithography, there is a direct unlock in increasing transistor density. If we can increase the power of the light that reaches the wafer, then what that allows us to do is manufacture more a high aspect ratio feature, more three-dimensional features on the chip that applies to both the next generation of transistors, but also these emerging architectures.